In this video, we'll be talking about the disk method. Suppose you are given a curve and it had said that it will revolve around the x-axis. So it will revolve around this. And you have the point of A and B. If you will revolve this, it will take the shape of something like this. Wait, I apologize for my drawing. So it will be something like that. So that is the graph if you're confused. And so in order to find the element, it will be perpendicular to the axis of rotation. Suppose in this case it is x. And so our element here should be a vertical element since it is perpendicular. So it will look something like that. We will take a slice basically. And so if it's in 3D, it will look something like this. Let me just draw it into another perspective. So it will look something like this one. And so the radius here would be respect to y. And the height here in this case, or the thickness of this disk, would be equal to height since it is a cylindrical disk. And so the volume of a cylindrical disk would be equal to the cross-sectional area multiplied by height. And so the cross-sectional area of a circle would be equal to pi multiplied by radius squared and multiply this by height. We can rewrite h as dx in order to represent all the height in every disk that we have formed. And so this would be the formula for one disk. But what we want is the whole volume of this solid. So what we're going to do here is to add all the disks that we will get. And since this is the same formula, we will just use the integral because basically it is summing up all of it. So volume would be equal to the integral of b, which is the upper limit, and a, which is the lower limit, of pi r squared of dx. Or you can put it as pi radius of y squared of dx. This can be the formula when it is on the rotation of x-axis. Now, let us move on to the rotation in y-axis. So we will revolve around this. Next, suppose we have a curve that looks something like this. Wait, let me just... something like that. And we have a point of C and D here. If this curve, or I mean if this will be rotated amongst the y-axis, its shape would look something like this. Something like that. And so, in order to find the element, once again, it is perpendicular amongst the axis of rotation. Since our axis of rotation is y, our element should be a horizontal element. So this will be something like that. If you put this amongst the solid, you will have something like this. Put it another perspective again of the disk. Something like that. You have the same disk as earlier. That is why this topic is called disk method, because you are using disk to calculate the volume. And so our radius here would be equal to r with respect to x now, and the height here would be equal now to dy. And so our volume for this would be equal to the integral of upper limit of d and lower limit of c of pi r squared of dy. Let us try some examples. Find the volume of the solid form when x equal y is revolved around the x-axis from x equal 0 and x equal 2. First step would be to plot this. For this x equal y, it is a linear, so it is simply a straight line. X equal 0, and x equal to 2, so it will be in here. And since our axis of rotation would be x, our element right here now should be a vertical element. Let's call this radius respect to y. Keep in mind that radius with respect to y is simply just y. So first, let us plot the points of intersection. If x here would be equal to 0, let us base this upon this x equal y equation. Y here would be equal to 0. Coincidentally, if y here is equal to 0, x right here would be equal to 0. So next step is to plug in this given. If x right here would be equal to 2, then y right here would be equal to 2 also. So our points of intersection would be 0, 0, and 2, 2. Plotting these points of intersection, this would be 2 and 2, and this would be 0 and 0. Thus, we can now compute for its volume. Since it is around the x-axis, it would be integral of 2 and 0 pi r here, radius of y is simply y, and so the value of y would be simply x. R here is squared of dx. We can put pi outside the integral, and so this would be x squared of dx. Integral of x squared would be x cubed over 3 with the upper limit of 2 and lower limit of 0. Computing this indefinite value, we would have 2 cube over 3 minus 0 cube over 3. This would be equal to 0. So what we are left with here now is pi multiplied by 8 over 3. So the final answer here would be equal to 8 pi over 3 cubic units. Remember to put cubic because it is a volume. Find the volume of the area bounded by y equals x squared, x equal 1, and revolves around the x-axis. First step again is to plot this. Y equals x squared. This is an exponential form, so it will roughly look something like this. Wait. Something like that. And what we have here is x equal 1. We can just put something here. This is x equal 1. This curve right here would be equal to y equals x squared. And it revolves around the x-axis. So in here again. So this is the area bounded by all of this given. So since our axis is x, our element right here now should be vertical. So radius with respect to y is simply y. And now our volume right here. Wait, we can first plot points of intersection. Let us base it on this equation. If x right here is 0, y is 0. If y is 0, x also is 0. And if you use this given, if x would be equal to 1, y right here would be also 1. So the points of intersection would be 0, 0, and 1, 1. So this points of intersection right here is equal to 1, 1. And for this, it is 0, 0. And so the volume right here, this is equal to 1 and 0. Would be equal to integral of 1 and 0. Pi, we can just put it outside. R here is equal to y. Y here is x squared. Oh, wait. If you are confused, let us just put the given first. Radius squared with respect to y of dx. And so radius squared of y would be equal to y, which is x squared. Raised to the power of 2 of dx. And so this would be pi integral of upper and lower limit of 1 and 0 of x to the power of 4 of dx. Integral of x to the power of 4 would be x to the power of 5 over 5 with the upper and lower limit of 1 and 0. So this would be pi multiplied by 1 to the power of 5 over 5 minus 0 to the power of 5 over 5. This will equal to 0. And so this should become pi multiplied by 1 over 5. Thus the final answer would be equal to pi over 5 cubic units. Find the volume of the solid form when x would be equal to the square root of y and revolves on y-axis from y equal 0 and y equal 4. First, let us plot this. And it said that it revolves on y-axis now. So, first let us plot the curve of x equal square root of y. Just in case you are not familiar with your curves, let us use the table method. If y here is equal to 0, x right here also would be equal to 0. If y is equal to 1, we are basing this according to this equation. If y right here is equal to 1, the square root of 1 would be simply 1. If y here would be equal to 4, the square root of 4 would be equal to 2. And so I think this is enough plotting, because we have achieved our goal, y equals 4. So that is enough. And so we'll plot the curve here. So this would be 0, 0, 1 and 1, 2 and 4. So it will be something like this. Now that we have that, let's get on to y equal 0. It would be in here. And y equal 4. So it will be in here. And since we are revolving this on y-axis, it will be something like this. So the area bounded, this will be it, and it will revolve around the y-axis. And so our points of intersection, let us base this against this curve again. If x right here would be 0, y would be 0. And if you're going to put this form given, if y here would be equal to 4, square root of 4 would be simply 2. And so our points of intersection would be 0, 0 and 2, 4. So this right here is equal to 2, 4 and 0, 0. Let me just clean this up first. Now let us start computing this. But first we shall identify element. Since our axis of rotation is y-axis, our element should be horizontal. So this would be radius x. Radius with respect to x is equal to x, or the value of x. So we can rewrite this as simply x. And so volume would be, c right here is 0 and the value of d here is 4. So the volume would be integral with the upper limit of 4 and lower limit of 0, pi r of x, and since we are rotating this on the y-axis, put dy in here. Since r of x is equal to x, let us compute the value of x according to this. So x right here would be square root of y. So rewriting this, we would have pi integral of x squared of dy, or the value of x right here is square root of y, So what we have here is this. And so the square root and square would cancel each other out, so you're left with pi integral of y dy. Integral of y dy, it would be simply y squared over 2 with the upper limit of 4 and lower limit of 0. So solving this, four squared over 2 minus 0 squared over 2. This would be equal to 0. So you are left with here is pi multiplied by 16 over 2. And so the final answer would be simply 8 pi cubic units. Find the volume bounded by y squared equal 12x, x equal 3, and revolves around the x-axis. Plotting this, since this is a find the volume bounded by y squared equal 12x, x equal 3, and revolves around the x-axis. Plotting this first. Plotting this equation, y squared equal 12x. This is a parabolic equation, and since this is positive, it will open towards the right. And so it will be something like this. Or if you can still memorize it, you can just use the table method as earlier. X equal 3. Let me just plot some points here. So this should be x equal 3. And it revolves around the x-axis. So it will be bounded by the x-axis. So first, find the points of intersection. Basing on this equation, if x here is 0, y here would be also 0. If y is 0, x also would be 0. And if x would be equal to 3, 12 times 3 would be 36, and the square root of 36 would be 6. And so our points of intersection would be 0, 0, and 3, 6. So this would be 3, 6, and this would be 0, 0. So our element right here would be a vertical element. So this would be r of y. R of y would be equal to y. And y here would be equal to square root of 12x. And so the volume right here would be equal to pi integral of 3, 0 multiplied by r of y, or y squared of dx. Pi integral of y squared right here would be equal to square root of 12x squared of dx. This will cancel, so you are left with pi integral of 12x dx. You can put 12 outside, so you will have 12 pi integral of x dx. Integral of x is x squared over 2 with the upper and lower limit of 3 and 0. So solving this once again, you would have 3 squared over 2 minus 0 squared over 2. This will equal to 0. So you are left with 12 pi multiplied by 9 over 2. 12 divided by 2 would be 6 pi multiplied by 9. And so 6 multiplied by 9 is 54 pi cubic units. Find the volume bounded by y squared equal 16x, the x-axis, and it rotates around x equal 4. So this is a different problem from what we have. But first, let us plot this. Y squared equals 16x. This is the same as our previous problem because it is a parabola, and since it is a positive, it will go towards the right. Something like that. And the x-axis, this is the x-axis, and x equal 4. Let me just plot some points here. So this should become x equal 4. This is y squared equals 16x. And so it says here it rotates around x equal 4. It is not on x-axis or y-axis. So it will become like this, since it rotates around x equal 4. Let me just redraw that. So this curve here will rotate something like that. And so, how can we assign our element, I mean. So first, we will have to identify our rotation axis. Since this is our rotational axis, it is the same as the y-axis here. So this will become like that. And so our element right here would be horizontal. So it will be like this. You can just put your element anywhere you like, as long as it is within the curve. And so this is r of x. Or we can just assign this as x, since r respect to x is simply x. But since we are not in the x-axis or y-axis rotation, we would have to subtract based on our axis of rotation. So what we have here is 4. So this would be 4 minus x. Because imagine if you were to put your element right here or element right here, you would notice that this element is bigger than this. So what we're going to do here is to just simply generalize your equation. So just put 4 minus x, because that is true whether it is in this element or this area. The reason we did not do this when it is around here or x-axis, it is because x-axis and y-axis is equal to 0. So putting x minus 0, x minus 0 or rx minus 0, it is not necessary. So we just simply put x or rx or y. And so that we have this, we can now solve. But first, let us plot out points of intersection. We'll base it based on this, y squared equal 16x. If x0 is 0, y would be 0. If y is 0, x also would be 0. And if x equal to 4, 16 times 4 would be 64. Square root of that would be 8. And so our points of intersection would be 0, 0, and 4, 8. So this would be 4, 8, and this would be 0, 0. So let us compute now for the volume. Since this is on y rotation, our upper and lower limit will be based on this one and the lower. So this is 8 and 0. So this should be integral of upper limit of 8 and 0. We can put pi outside. 4 minus x squared of dy. And so our value of x right here, since this is dy, we must put this in terms of y. So based on right here, y squared equal 16x. Divide both sides by x, by 16 I mean. So x right here would be equal to y squared over 16. So we will plug this in. Of dy. So power of square formula, this should be 16 minus 2 multiplied by 4 would be 8y squared over 16. 8 divided by 16 would be 1/2. So this is simply y squared over 2. Plus y to the power of 4 over 16 times 16 would be 256 of dy. Integrating each of this, integral of 16 dy would be 16y minus integral of y squared over 2. Wait, let me just simplify this. Integral of y squared over 2. We can put 2 outside the integral. So this would be y squared dy multiplied by 1/2. So it would be 1/2 multiplied by y cube over 3. Or it will be y cube over 6. Plus integral of y to the power of 4 over 256. We can put 256 outside of dy. So this would be 1 over 256 multiplied by integral of y to the power of 4 would be y to the power of 5 over 5. And so this should be y to the power of 5 over 1280. So those are the integral and the upper limit of 8 and the lower limit of 0. Solving this, we would have pi all multiplied by 16 multiplied by 8 minus 8 cube over 6 plus 8 to the power of 5 over 1280, and let's subtract that by and let's subtract that by 16y or 16 multiplied by 0 minus 0 cube over 6 plus 0 5 over 1 to 80. But since this is all equal to 0, so it is negligible. So we'll just focus on this. And so if you type this into your calculator, you would have around 1024 over 15 or 1024 pi over 15 cubic units, or 68.26 pi cubic units. The area bounded by the curve y equals e raised to the power of negative x, the x-axis, and the line x equal to, is revolved around the y-axis. Find the volume generated. So first, let us plot this given y equals e to the power of negative x. We'll use the table method here. If x right here is 0, so this should be y equal e to the power of 0. It is 1. If x right here is equal to 1, it would be negative 1. Calculating that in calculator, you would have a value of 0.37. If x right here would be equal to 2, calculating that, you would have a value of 0.135. And if x right here would be equal to 3, you would have a value of 0.05. So let us plot this. Let me just make this bigger so that it will make sense. So that x0 and y equal 1, x equal 1, and y equal 0.37. Let's just roughly estimate this. X equal 2 and y equal 0.135. And 3, it will be 0.05, so it will be very close to x-axis. So it will be something like this. Like that. So this should be equal to y equals e to the power of negative x. Next step is the x-axis. So it will be this one. And the line x equal 2. So it will be this one. And since we are revolving this around the y-axis, it will also be bounded on the y-axis. And so this is the area that is bounded. And so if we will revolve this around the y-axis, we can now compute for its volume. So our element right here would be a horizontal element. Let's just call this value of x for simplification now. Wait, first let us plot points of intersection. Let's base it according to this curve. Y equal e to the power of negative x. If x here equal to 0, y here would be equal to 1 as we did earlier. If y right here would be 0, x here would be ln y would be equal to negative x ln of e. Ln of e would be simply 1. And so, x right here would be equal to negative natural log of y. If y here is equal to 0, ln of 0, it is undefined. So, what does that tell us? It means that this curve right here, this would never, as long as it approaches infinity, it will never touch this x-axis right here. So, you cannot have a value of x here because it does not touch. So, undefined. And so, if x equal to right here, this would be 0.14 if you plug this according to this. So this would be 0.14 and 0, 1. And so that we have our points of intersection now done. We can now compute for the volume. Volume right here would be equal to the integral of, since this is rotating on y-axis, we will base our upper and lower limit according to this. So the upper limit would be 1 and the lower limit is 0. Pi x right here would be equal to, this was derived and you will have something like this. So x right here would be equal to negative ln of y. If you want the step, let me just repeat it. Take the natural log of both sides so that x right here would be, can be bring down. Ln of e would be equal to 1. And so we are now onto this step. So x right here would be ln of y. negative ln of y squared of dy. So let me just rewrite this. Volume equal pi integral of ln negative ln y squared is simply ln squared of y dy, upper limit of 1 and lower limit of 0. We cannot integrate this further without special means, so we will use integration by parts. Let us use the di table. So these are the two parts that must be used, ln squared y and dy. So based on the Layat rule, under derivative, we will put the logarithm first. So it will be ln squared of y, and integral is dy. The derivative of natural log squared of y would be chain rule first. So it will be 2 natural log of y multiplied by ln of y would be y prime over y, or the derivative of y is 1. So it will be 1 over y. So this can be put as 2 ln y over y, and the integral of dy is simply y. And so this should become like this. Ln squared of y multiplied by y. This can be y ln squared of y minus, for this, integral of 2 ln y over y multiplied by y of dy. Wait, this is kinda confusing, so let me just simplify this. Volume would be equal to pi multiplied by y ln squared of y minus integral of y here would cancel each other out, so you are left with 2 ln of y, or you can put 2 outside the integral. With the upper limit of 1 and lower limit of 0. So integrating ln y dy again. This is a repeat of integration by parts, so use the di table once again. Let me just put the di table in here. Under derivative, put natural log of y, and under integral, put dy. Integral of ln of y would be simply 1 over y. Integral of dy, in here, the derivative of ln of y is 1 over y, and the integral of dy would be y. So you are left with here is v equal pi all multiplied by y ln squared of y minus 2 all multiplied by ln y ln of y again minus integral of 1 over y multiplied by y dy. So y here would be equal to 1. So you are left with here is simply integral of dy. So it will be volume equal pi multiplied by y ln squared y minus 2y ln of y plus 2y, because you distribute negative 2 amongst this, so it will become positive 2y with the upper limit of 1 and lower limit of 0. And so we can finally compute this. This would be pi multiplied by, substitute 1 all amongst this y. So this would be 1 ln squared of 1 minus 2 multiplied by 1 ln of 1 plus 2 multiplied by 1. And if you put 0 all amongst this y, you will also get a total sum of 0. So no need to put it. Simplifying this, we would have pi multiplied by ln squared of 1 minus 2 ln of 1 plus 2 multiplied by 1. One thing you should know is that ln of 1 is equal to 0. This is because e raised to the power of 0 is equal to 1. And so what you're left with here is volume multiplied by pi equal 0 squared minus 2. Since this is also ln 1, this will be equal to 0 plus 2 multiplied by 1 and so what you're left with here is simply volume equal 2 pi cubic units.